Uh, Good day, class, and welcome back to my pre-calculus class. Last time we were looking at alternate forms of the Pythagorean identity, and I walked us through how to derive this Pythagorean identity through our usual friend, sine squared of angle plus cosine squared of angle, let's say t, equals to 1. So I walked us through how to derive these two other Pythagorean identity. And we used them to solve some basic problems. So today I will be continuing this study by looking at right triangle trigonometry. So today we're quickly going to be looking at how to use right triangles to evaluate trig functions and also to look at how to find function values for our special angles. We will look at the concept of cofunctions and the definitions of trig functions of any angle. We will also use right triangle trigonometry to solve applied problems. To start this, let us go back to our unit circle. A unit circle with radius 1. This is r. Radius equals to 1. We call this side x and we call this side y with our angle, which is c. Now, if we bring out this right triangle, we do have our angle here. Look at that. I'm just bringing out the right triangle here. And basically, I want to name this side. The side that faces our angle is called opposite. That side that faces angle 90 degree, this is angle 90 degrees. That side is called the hypotenuse side. And lastly, the side that is next to our angle is called the adjacent. So many of you know about this before this class, so I will not take too much time to explain that. So given a right triangle with an acute angle of t, our angle must be acute angle, that is angle less than 90 degrees. Then we say sine of angle t, or whatever the angle name is opposite over hypotenuse. Cosine of angle t is adjacent over hypotenuse, and tangent of angle t is opposite over adjacent. And if I do this, if I take that S from sine, and I take this O, and I take this H, then I have this. If I take this C, I write it in capital. This A, I have this, and this H, I have this. Again, if I take this T, I write it this way, then O and this A. Then I have what we can call a like a way to remember how the formula works, and that is SOHCAHTOA. SOHCAHTOA, with the first one sine, this cosine, and this tangent. So this means sine is equal to opposite over hypotenuse. Cosine of angle is adjacent over hypotenuse. And tangent is opposite over adjacent. So a common mnemonic for remembering this relationship is the SOHCAHTOA, like I just explained. Let us look at example. Given the triangle shown in the figure below, find value of cosine of alpha. So we have angle alpha here. So because this side is facing that angle alpha, it is the opposite. And this side is the one facing angle 90 degrees. So it is the hypotenuse. And lastly, this is the adjacent. Now we are looking for cosine of angle alpha, which is adjacent over hypotenuse. Do not forget from SOHCAHTOA. So we are dealing with cosine, so that is adjacent over hypotenuse. And our adjacent is 15 in this case, and the hypotenuse is 17. So that is our Answer, cosine of alpha is 15 divided by 17 in this case. I will leave you with this to just try it. There is nothing big deal here. You are just looking for sine of angle T, sine of angle T. And remember what sine is. You get that from this, opposite over hypotenuse. Okay, another example. Using the triangle below, evaluate sine of alpha, cosine of alpha, tan of alpha, secant of alpha, cosecant of alpha, and cotangent of alpha. Again, let us label this right triangle. I know it is right triangle because I have angle 90 degrees here. So in that, this side is the hypotenuse, and this is my angle. So this side is the opposite, and this side will be called the adjacent. Now, let us quickly find sine of alpha. Sine of angle alpha is opposite over hypotenuse. Again, from SOHCAHTOA. Okay, so opposite is 4 and hypotenuse is 5. Answer. Cosine of alpha is adjacent over hypotenuse. So which is, in this case, 3 over 5. Tangent of alpha, we can see tangent of alpha, that is opposite over adjacent, opposite over adjacent. So which is 4 over 3. The next, we look at secant of angle alpha. Remember that secant is the reciprocal of cosine of alpha, which is now 1 divided by the cosine of alpha. We know it to be 3 over 5. So the reciprocal of that would be 5 over 3. Cosecant of alpha. Remember that cosecant is the reciprocal of sine. So in this case, that is reciprocal of sine alpha, which is the reciprocal of 4 over 5, and that is 5 divided by 4. Lastly, we do have cotangent of alpha, again, which is the reciprocal of tangents of alpha in this case. So that is the reciprocal of 4 over 3. And we do have 3 over 4. So that is that about using SOHCAHTOA. It is as simple as that. Another way to find this secant, cosecant, and cotangent. If you go to, you do know, or we do know that cosecant is the reciprocal of sine. So here you just swap this. So that is HO. Secant is the reciprocal of cosine. So here it is HA. That is hypotenuse divided by adjacent. And lastly, cotangent is the reciprocal of tangent. So here we can use AO, that is adjacent divided by opposite. And you will still get this answer. All right. So I will leave you with this to find the trig values of of this angle. So it is simple. Just find it using this triangle. Okay. Now, the next thing we want to look at is the concept of side lengths. Let us look at the concept of side lengths. Let us look at the, sorry about that, I need to, okay, the concept of side lengths. Now, let me show us something beautiful again. So, suppose we have something like this. Our unit circle, and let me call this place angle pi over 3. Now, I can have something like this. So, if this is pi over 3, then here will be pi over 6, that is 30 degrees, since pi over 3 is 60 degrees. Okay, now, if I have these, well, I don't really need that, but let me use this line. Okay, now, I want to call this place side. I want to call it side, just a side. Let me bring it out so that you can see it clearly. Okay, so I want to call this place side. Instead of writing the whole side, I will just say S. I will just say S. So a side. Now, looking at this, from here to here, I'm calling it side. Since this is a perpendicular bisector of that line, now it then means that this other part is the same as side in terms of length. Now, it turns out that I'm saying that the radius is 2 sides. Okay, now if that is true, remember that from here to here is the radius of that circle. So which means I can also call this place 2 sides. So I will say here is 2s. This is pi over 6. Okay, now I can find, let me call this place y. This, that vertical part. So let me call it y. I don't know it. We can find it using Pythagoras theorem. So from Pythagoras theorem, from Pythagoras, y squared equals to 2s squared minus s squared, right? This is the longest side. So if I want to know the other side, I need to subtract the square of this other length from the square of the hypotenuse. Therefore, y squared equals to square of 2 is 4, square of s is s squared minus s squared. And y squared equals to 3s squared. If I take the square root on both sides, I will have y equals to plus or minus root 3s squared, which is the same thing as plus or minus root 3 plus or minus root 3s. I'm going to say my answer here is y equals to square root of 3s positive, since I'm dealing with this first quadrant. Now, we do have this triangle now. We do have these. So this is pi over 3. This is pi over 6. And this is 90. So we say here is root 3s. Here is side. Here is 2 side. That is 2s. Now, let us see. We can find sine of 60 degrees or sine of pi over 3, which is, let me use pi over 3, sine of pi over 3. Remember from SOHCAHTOA, sine is opposite over hypotenuse. So which is our opposite to this angle 60 degrees is root 3s divided by hypotenuse is 2s. And SL1, SL1. And my answer there is root 3 divided by 2, which is the same thing we've had for the sine of pi over 3. So that is another way to see the derivation of the sine and cosine of our special angles. Another one is sine of, let's say, well, let's go for cosine first. Cosine of pi over 3. Pi over 3. Cosine is adjacent divided by hypotenuse. So to this angle, this is the adjacent. So s, and hypotenuse is 2s. Therefore, SL1, SL1. And I have 1 over 2 as the cosine of cosine of pi over 3, that is 60 degrees. Now, again, let us look at sine of pi over 6 now. Sine over pi over 6, 30 degrees. So which is, again, opposite over hypotenuse. So which is opposite to angle 30 degrees, pi over 6. Opposite to that is s, and hypotenuse is 2s. So which is, again, SL1, SL1. And we have 1 over 2. And lastly, cosine of pi over 6 is adjacent divided by hypotenuse. Adjacent to this angle pi over 6 is root 3s divided by hypotenuse is 2s. And that is SL1, SL1, and we do have root 3 divided by 2. So again, we have cosine of pi over 6. Now, we notice something. Let me see. Okay, we've now answered this example. We've answered this example. Okay, now I want to introduce something. To do that, we can see. So that is what I did here. You can also look at the same thing for pi over 4. So here I call it a side. And since this is pi over 4, this is pi over 4, they're the same. So definitely this side will also be s. And if you use Pythagoras, you will get this side to be root 2s. And you can do the same thing to find cosine of pi over 4, sine of pi over 4. In fact, tangent of pi over 4. From this example, you will notice that the value of sine pi over 3 is the same thing as cosine of pi over 6. And the value of cosine of pi over 3 is the same as the value of sine of pi over 6. That means something is happening here. can I say that if I know, okay, now I can say that sine of 30 degrees is the same thing as cosine of 60 degrees. That is what we see from our example. Now, I can smartly do something and say, it turns out that whatever angle is here, let's say 30 degrees first, I can rewrite this as 90 minus that 30 degrees. I will still have my 60 degrees. I hope that makes sense. Now, I can then say that sine of any angle is cosine of 90 minus that angle, whatever that angle is, insofar it is an acute angle. So then we come about what we call cofunction identity, the idea of cofunction identity. What does it mean? The word or the prefix there, if I may call that, co, that is together. They are together, right? So cofunction, sine, cosine. Does that make sense to you now? Sine, cosine, tangents, cotangent, secant, cosecant. So let me show you. Look at it. Sine, cosine, tangent, cotangent, secant, cosecant. They are cofunctions. In general, we say, if I know the cosine of an angle, of an acute angle, the sine of that, the sine of the angle that will be equal to the value of the cosine of that angle will be, just subtract this angle from 90 degrees. The same thing, I can work also from sine, just subtract that angle from 90 degrees. Just like if I ask you, what will sine 30 degrees be equal to? That would be cosine of 60 degrees. How do I know? Just subtract this from 90 degrees. I hope that makes sense. Let us look at it from example perspective. Sine of angle is 5/12. I want to find cosine of pi/2 minus that angle. We don't even know what the angle is. Now, remember that we have this relation, sine of angle is cosine. If I want to know what that sine of angle will be equal to in terms of cosine, I just need to subtract that angle from 90 degrees or from pi/2. Therefore, look at this. This is what we are looking for right here. And we have this already given, which is 5/12. Automatically, cosine of pi/2 minus t is 5/12. Let us look at another example. Let us look at this example. We are given that cosecant of pi/6 is 2, and we want to find secant of pi/3. Remember, secant and cosecant. Secant and cosecant. That is their cofunction. So it then turns out that I can say secant of pi/3 will be cosecant of pi/2 minus this angle, which is pi/3. And that is cosecant of This is 90. This is 60. 90 minus 60, that is 30, which is pi over 6. And guys, I've been given the value of pi over 6 to be 2. So it turns out that secant of pi over 3 is also 2. Okay, next thing we will look at how to use trig functions to find lengths of right triangle. So let us look at an example. Find the unknown sides of the triangle below. Okay, we don't know this side, we don't know this side. We do know this side. If this is 90 degrees, then here will be hypotenuse. And this is our angle given. Here will be opposites. And here will be adjacent. Now, maybe we should find C first. Or A, it doesn't matter. So this is adjacent. And we have opposites. Adjacent and opposite. Remember, we can say tangent of angle 30 degrees. That is from SOHCAHTOA. We have opposites and we have adjacent. So I know what brings them together is tangent. So tangent of 30 degrees equals to opposite 7 over adjacent, which is A. Now I can say this is over 1 and I can cross multiply here. So that is A tangents of 30 degrees equals to 7 times 1, 7. Since I'm looking for A, I can divide through by tangent of 30 degrees, tangent of 30 degrees. And I will have this takes care of this, and I have A equals to 7 divided by tangent of 30 degrees. Now, what is tangent of 30 degrees? We can quickly work it out somewhere on our paper. We don't need to memorize that. We can work it out. We do know that tangent of 30 degrees is the same as sine of 30 degrees divided by cosine of 30 degrees. Now, sine of 30 degrees is 1/2. And we are dividing that by cosine of 30 degrees, which is root 3 over 2. And now we have 1/2 times 2 over root 3, which is 1 over root 3. And if we rationalize this, root 3 over root 3, we will have root 3 divided by 3. That means here we have 7 divided by tangent of 30 is root 3 over 3. And we have 7 times 3 over root 3. Okay. Here now we do have 21 divided by root 3, which we can rationalize this again. So that is times root 3 over root 3. And we have 21 root 3 divided by 3. So which is 7 root 3. Answer for that. Okay. Now we can find C. We can find C. Let us find C. Now, to do that, we would observe that this is hypotenuse and this is opposite. So what brings them together is sine. So we have sine of angle 30 degrees equals to opposites over hypotenuse, which is 7 over hypotenuse is C. Okay, that is, we have sine of 30 degrees equals to 7 over C. We can say this is over 1, and we can cross multiply. And then we have C times sine 30 degrees equals to 7 times 1, which is 7. And then we can divide both sides by sine 30 degrees, sine 30 degrees, divide this, sine 30 degrees. And now we have this takes care of this, and we have C equals to 7 divided by sine 30 degrees is 1/2, and that is 7 times 2 over 1, which is 14. So that is our answer. I will leave you with this problem. So you should pause the video and try this. A right triangle has one angle, pi over 3, and a hypotenuse of 20. Find the unknown sides and the angle of the triangle. So you should be able to draw a right triangle, identify the angle 90 degrees, then label one of the remaining two angles, label it pi over 3. And then you can identify the hypotenuse and then find the other sides that we don't know and the other angle, which is easy to find. Okay, moving on. Let us measure distance indirectly using right triangle trigonometry. In this case, we want to apply it to real world problem. To find the height of a tree, a person walks a point 30 feet from the base of the tree. Well, how does a tree look like? A good tree should be something maybe even better than that. Something like this, straight. A good tree should behave that way. Now, to know the height of this tree, let's say this is the tree and the roots, the ground. So to know the height of this tree, a person walks 30 feet, 30 feet away from the base. And now we have the person here who wants to know the height of the tree, the height. She measures an angle 30 degrees between a line of sight to the top of the tree and the ground. So she's looking up there and measures that the angle between the line of sight, the line through which she's seeing the top of the tree, and the ground is 30 degrees. So we can use the idea of SOHCAHTOA to find the height of the tree. Again, since our angle is here, this is opposite. This is angle 90 degrees, so this is hypotenuse. Now, this is the side we know. So this is the adjacent, and this is the side we are looking for, which is opposite. Again, the relationship there is tangent, opposite and adjacent, toward. So that is tan of angle 30 degrees equals to opposite, which is h, divided by adjacent, which is 30 feet. Remember, we find that, okay, before that, you can say over 1 and divide this. H times 1 is h, and 30 times tan 30 is 30 tangents of 30 degrees. So this is 30 times tangent of 30. You should know it the way you know sine of 30, cosine of 30, sine of 60. Cosine of 60, you should know tangent of 30 as well. If you remember, we find it the other time um to be root 3 over 3. Remember, we find it here, and we find it to be root 3 over 3. So we can say 3 here 1, 3 here 10, and our answer will be 10 square root of 3. You do not need to do anything to this other than just put the unit. We know the unit to be feet from the problem statement, feet. So that is 10 root 3 feet. And just leave your answer like that. I hope that makes sense. Once you are able to draw the diagram to represent the situation using diagram, then every other thing becomes the job of SOHCAHTOA. Okay, in this problem, we want to find the value of x. This is a little bit more than what we have seen, in that we are having a situation whereby we are not looking for the whole length here, we are looking for just a part of it. However, we notice that we can form two triangles from this diagram. The first one is something we have this way. We can form this right triangle where here is 35 degrees and here is 115. And the other one is a smaller right triangle as well. Here is 56 degrees. This is also 90, and this is 115. Now, what we notice is that from here up to this place represent the entire length for that big triangle. So let us call this maybe y, and let us call this smaller side, this part here. So let us call it can call it anything, let us call it a. We can say that x that we are looking for is when we subtract that small a, that smaller length. So here now is a. So when we subtract, so the whole thing, we are calling the whole thing y. So if I subtract a from y, I will get x. Now let us see if we can form something from this triangle and this triangle in terms of for y and for a. Okay, in this triangle, y is adjacent, and this side we're giving is opposite. So again, tangent is what brings them together. Now we have tangent of 35 degrees equals to opposites, which is 115 divided by adjacent, which is y. Therefore, I can say y equals to 115 divided by tangent of 35 degrees. Similarly, from this other triangle, we can see that tangent of 56 degrees equals to opposite, which is 115, divided by adjacent, which is a. And therefore, a equals to 115 divided by tangent of 56 degrees. Therefore, our x now equals to y minus a. Our y is 115 divided by tangent of 35 degrees minus a is 115 divided by tangent of 56 degrees. Okay, now we have that this is equal to 115 divided by, we were given here that tangent of 35 is 0.7002 minus 115 divided by tangent of 56 is 1.4826. So, insofar in most calculus classes, we do not use calculator. So, we can just leave our answer this way. And just leave our answer this way since we do not use calculator. And if you're allowed to use calculator, you can go ahead and just put that in your calculator and get the final single value for x. Again, I will leave you with this problem to solve. How long a ladder is needed to reach a window sill 50 feet above the ground? That window sill is 50 feet above the ground. If the ladder rests against the building, making an angle of 5 pi over 12 with the ground, ran to the nearest foot. So again, draw the triangle or the diagram that represents the situation and find the length of the ladder. So that is where I'm going to be ending this particular video. In my next lesson, I will be looking at graphs of the sine and cosine functions. So for now, I hope you enjoyed this video. You can like it, you can share it with other people that you think may be that the video may be helpful too. So till my next video, keep enjoying maths and see you in class. Bye-bye.